So, warm welcome to the 24th lecture on the subject of digital signal processing and its applications. We have been discussing the Chebyschev low-pass filter in the previous lecture, and we have already talked about the Butterworth filter in a couple of lectures before that, where we observed some interesting engineering behavior of the Butterworth filter. Namely, if you wish to place more stringent demands, then you need to invest more. This is an observation that we made for the Butterworth filter. Now, we have in the previous lecture been able to come up with an expression for the order of the Chebyschev filter. Let us put down that expression. Now, essentially in the low pass filter design, we need to determine epsilon, which is what is called the tolerance parameter or ripple, and the order. Which is essentially given by cosh inverse. We've seen this last time, haven't we? Cosh inverse d2 by d1 square root divided by cosh inverse omega s by omega p. Now, in the tolerance or the ripple epsilon, we saw that epsilon is less than equal to, of course, you always want it to be small if possible, less than equal to square root of d1. But we also made an observation on why we should choose epsilon equal to square root of d1 last time. In fact, if we look at this expression, we now make some observations about the behavior of the order with respect to d2, d1, omega s and omega p, or rather the ratio omega s and omega p. Let us review a few ideas here.